Hi friends, welcome to GMK tutorials. In this video, we are going to see about the first order derivatives for image sharpening. So generally, the procedure for finding the first order derivative by using a image gradients. So the first order derivatives in the image processing are implemented using the magnitude and gradient. First order derivatives in the image processing are implemented using the magnitude and gradients. So here f of x comma y is nothing but a function. The gradient of f at any coordinates x comma y is defined as two-dimensional column vector, that is nothing but gradient of f is equal to g of x and g of y. It can be represented dou f by dou x and dou f by dou y. That means gx is equal to dou f by dou x, gy is equal to dou f by dou y. Okay. Now, so by the mathematically, the magnitude of the vector can be represented as m of x comma y is equal to magnitude of this one. That means it is the square root of gx square plus gy square, as well as at a corresponding coordinate x comma y. The rate of change of direction of the gradient vector, is can be given because so that magnitude value gives the rate of change of corresponding changes in the intensity values, as well as m of x comma y is the image of the same size. The original image it referred as a gradient image, simply called as a gradient. So it is referred as a gradient image or simply as a gradient when the meaning is clear. So the components of the gradient vector are derivatives. They are linear operator. The components of the gradient vector is derivatives, like gx is equal to f by dou x. So we can also call it derivatives. The magnitude of this vector is not because of the squaring and the square root of the operation. Okay, so as well as the partial derivatives in the equation are not rotational invariant. It is not a rotational invariant. So here g of x, so that means the complete product can be sum. It is approximately equal to this one. So this is a 3 by 3 matrix. So these are the robust cross gradients operators that is already predefinedly available. We have some basic knowledge. These filters also called as the Sobel filters for detecting the horizontal and vertical lines. So based on the Sobel gradients, gx is equal to z8 minus zy and gy is equal to z6 minus. These are the sum of the equations we will take in from the corresponding 3 by 3 matrix window. So gx is equal to dou f by dou x. That means if you are taking the last row minus first row, that gives us the first equation. Gy is nothing but it's the difference of the last column and first column. You will get like this. With the help of these two equations, if you are writing all the equations in some order fashion, you can represent the gx and gy equations mathematically. So m of x comma y is nothing but the magnitude of that one. So g of x plus g of y based on the previous two equations. The mask of the figure D and E are called as a Sobel filter. That means if you are writing the corresponding equation, that means based on these two values, if you are generating a 3 by 3 matrix, it produces a Sobel operator. So because of so Z7, Z8, so Z7 1 2 1. So here we are getting -1, -2, -1. So these values are 0. So this is nothing but a Sobel filter based on the corresponding two equations, whatever we are getting in the so the idea behind using the weight value of 2 in the center coefficient is to achieve some smoothing by using giving more importance to the center point. So that means if you want to attaining a smoothing value, more moving from the central pixel. So for that purpose we are giving the more weight to the central pixel, as well as the coefficients in all masks to sum to the indicating that they would give a response of 0 in the area of constant intensity. Wherever the constant intensity is there, at that time if you are summing all the values, we can get a final value is equal to 0. So that is also one of the excellent features, as well as the computations of gx and gy are linear operation because they involve derivatives therefore can be implemented as a sum of products using a spatial filters. So these filters are a non-linear filter. That's why we can produce the corresponding filters by multiplying the convolution operations, like we can summing up that value, we can get the values also. The nonlinear operators of the sharpening with gradient is that competition of the m of x involving a square and square roots. So the magnitude of the gradient is a nonlinear operation because of it involves square root values as well as square values also. So all which are nonlinear operators. So these operators are performed after linear process that yields gx and gy. So this is just a brief introduction about the gradient, first order derivatives. We can also call this a first order derivatives for image sharpening. First order derivatives for image sharpening. So thank you for watching GMK tutorial. Thank you.